Well, you didn't have to fold it, but that's cool. Because we're going to cut it in half. See how I just went through it like that? And I'm going to cut all the way around it, except you're going to cut yours. We only have one scissors. So I'm going to cut it, I'm going to come around, I'm going to go like this. I'm going to be careful not to go out the sides till I've got it all the way around the cut.
Wait, where did I start?
You have to, well, I started where I did the tape, so I didn't have to fool with it at the end. I did it at the beginning. Yeah. Okay. So, Tyler, since you're our host tonight, one of them, we'll make you the one who makes the mistake.
All right.
If I cut this down the middle, how many pieces will I have?
Still one.
How do you know? You're right.
It's still one piece of paper.
Okay, he's right. Would everybody have still said if you cut something down the middle, you only have one? Okay, go ahead and cut it down the middle. He did it. He wrecked it. You blew it. You destroyed my optical illusion.
Sorry.
Okay, go. Oops, he's still going. Be careful you don't catch that edge.
Oh, now I see it.
Okay, connect it. Cut it, and right down the middle, you cut it in half. And how many do you have? You have one. So I was just using this as an analogy that you would think that when you cut something down the middle in half, you would have more. You would have two. Of course, you cut it in half again, and something completely different happens. But that's a distraction, so I won't go there. Okay, so base 10 system. We were taught another optical illusion. Let's see if everybody gets it. This is 10 fingers, correct? How many fingers is this? 10. False. Okay. Our thumbs are opposals. That's called bilateral symmetry. There's an axis down the middle. These are 50-50. They're half of a whole, which is 100%. In other words, because they're mirrored, they're inverted. They're a reflection of each other. There's not 10 here. If the thumb had been over there, it would have been 10. But because the thumbs, because it shows that there's a focal center, an axis, a line in the middle, because it's based on spin physics, because there's a symmetry here, it's called parity, it's half. So we don't have 10 fingers. So the powers of 10 come from, wait, keep that there. Oh, I'm stiff. Let's see what pen to use. So without trying to be theatrical, I'll just go to the answer. Okay, so this symbol is the secret of everything in the universe. There isn't anything that exists that's not contained in it. As you half, you go to 0.5, and that's 5/10. It's because these are halves. So every time you half, you increase to 0. Half of 0.5 is 0.25, okay? Now, first of all, I ended up on the 7 there. You know this is just a circle, 360 degrees. It's just 1 through 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That would have been 10. But 1 plus 0 is 1. That would have been 11. 1 minus 2. That would have been 12. 1, 2 is 3. I'm just using single digits because I'm not looking for the number. I'm looking for the pattern. Okay? And the patterns are everything because I use it to navigate. Okay, half of 0.25. Oh, yeah, and that's 25 hundredths. And the powers of 10 is 1 times 10 is 10. 10 times 10 is 100. 10 times 100 is 1,000. It's just powers of 10. 100,000, that's 10n. Okay? And so a half of 0.25 is 0.125, which is 125 thousandths. Okay? And of course, but you don't know this yet, 1 plus 2 plus 5 equals 8. Because I'm referencing these points by many different ways. I'm representing them by the value, the 0, by all different things. And that's why this math has real good endorsements in it, because it says I have the most coherence, the most regularity ever done in mathematics. Russell Blake said that if anybody had told him about my work before he had met me, he would have said that it was impossible. So half of 0.125 is 0.0625, which equals 13, which equals 4. By the way, I didn't keep going around because I discovered that a circle, like us with an axis, with our hands, everything's created from the inside out. Okay? And that's how you control electricity, that's how you control magnetism, because then you have a focal center and you have an axis. Everything is a gyroscope. even numbers, okay? Because numbers are real, and because nature is expressing herself with numbers, which is quite a discovery, okay? So this is 625 10,000s, okay? That's 10 times 1,000 10,000s, and 6 plus 2 plus 5 equals 13, 1 plus 3 is 4. And I'll do one more. Half of 0.0625 is 0.03125, which is 3,125 hundred thousandths. Okay? And 3 plus 1 plus 2 plus 5 equals 11 equals 2. Okay? So it's not that we have 10 fingers that you have powers of 0. Oh, it looks like 10. It's because every time you half, you increase a 0. Okay? There is a correct and a right answer, and not just a flippant answer, such as we have 10 fingers. Okay? So we started from here, which was, this went from 1 to 10 to, oops, that should have been 100, to 100, that's 25 hundredths, to 1,000, 625, 10,000, 325 hundred thousandths. This will become a million. We went from 1 to a million to a billion. What they're doing is they're being sorted. They're going through a grate. Okay? Hundreds are always in the middle. This goes from 100 to 100,000 to 100 million to 100 billion to 100 trillion. Even numbers are being graded, just like you go through a screen. Okay? Your tens are at the bottom. 10, 10,000, 10 million, 10 billion. Okay? Let's go in the opposite direction. Now, this is the language of computers. Say it again.
10 jillion?
10 jillion? How do you spell that? Is there really a jillion?
Yes.
There is? Wow. Yep, 10 jillion. 10 jillion will be on that row. I don't know if it'll be on the left or right, and that makes a big difference because that determines polarity, whether it's positive or negative, but it will be on that row.
Jillion is infinite.
Jillion means infinite?
No, infinity does.
Huh?
Infinity does.
In this work, it shows that infinity does not exist in our world of the third dimension, the physical world, because we tend to define infinity as endless. And what infinity is, your lazy 8, is infinity of a spin continuum. It's infinity of duration, it's infinity of motion, but not infinity of direction. And I figured out the numerical pattern for infinity.